Hello, welcome back. Sorry, welcome back. So now we're going to start doing some optimization problems. Okay, so let's see. Optimization. Now, when you do optimization problems, there's actually two things you have to consider. Okay, there's what is it you are optimizing? And two, which is actually almost more important, what constraints do we have? Okay, in real life, people like to think about what are we optimizing, but they don't like to think about what are the constraints. Okay, for example, I would like everyone to study 5 hours a day of calculus, but you have other classes. Those are your constraints. You have other things in your life. Okay, all right, so let's go ahead and get started. This is the first one. This one's like a Calc 1 problem, but we're going to revisit it. Okay, so and we want to optimize x times y with the constraint that x plus y equals, let's say, L. Okay, so this is sort of maximizing the area of a rectangle with the consideration that you have a given perimeter. Okay, that's equivalent. So we're going to do this a couple of ways. The first way we're going to do this is we're going to do it directly. Can't spell. I should optimize my spelling. Okay, so what we're going to do when we do this directly is we're going to take f of xy equals x times y. We're going to take our constraint. Okay, and this constraint means that y equals L minus x. And so we can have f of x equals x times L minus x, negative x squared plus Lx. And we're going to take the derivative there. Negative 2x plus L, set it equal to 0, and that gives us x equals L over 2, which gives us y equals L over 2. So the maximum is actually L squared over 4, okay? And it's with x equals L over 2, y equals L over 2. So what we've done here is we've effectively used the constraint to reduce the dimension of the problem. Okay. Now we're going to actually learn another way to look at this. Okay, give me just a second. There we go. Okay, we're going to learn a way called Lagrange multipliers. Okay, so let's pretend we're not going to really get into the theory of it at all. Okay, we're not. It's requires a little bit more than we have in Calc 3, but we can use it. Okay, so the idea of Lagrange multipliers is if you are given um, let's say f of x1 through xn, okay, with constraints g1 of x1 through xn equals, let's say, c1. And you should have at least n minus 1. We're not going to do all of these. Okay, then the gradient of f should equal, I should say, alpha 1 gradient g1 is alpha 2 gradient g2. Let's actually change that to lambda. We're not going to do all this, don't worry. This is just for my own mathiness. Okay. What it really comes down to, though, in practice, or at least in our practice, okay, is that if we have f of xy, we want to maximize or optimize, with constraint g of xy equals, let's say, c, then we seek the gradient of f equals lambda gradient of g. Okay, so let's do this for this exact problem that we just had. So I'm going to go to another page here. Okay, so let's revisit that problem. Okay, so we want to optimize, or we want to maximize f of xy equals x times y, okay, with the constraint that g of xy equals x plus y equals L. Okay, so we're going to do this with Lagrange multipliers. The gradient of f. Well, the gradient of f equals, the first term is the derivative of f of xy with respect to x. That's simply going to be y. Second term is x. That should equal the lambda of gradient of g. That equals, in this case, the gradient of g with respect to x is 1. The gradient of g with respect to y is 1. So we're just going to get 1, 1. So what do we get? We get, running this through, we get y equals, I forgot my lambdas here. Y equals lambda, x equals lambda. So I actually don't need to know what lambda is, all right? But what I get here is that x and y are the same. So from the constraint, I get that x and y are both L over 2. Okay? All right. We're going to come back. I'm going to do a couple more problems in the next video.